Hello and welcome back to Mr. Powers Teaches Algebra. In the last video, in these videos, we're talking about transformations. In the last one, we did vertical shifts. And now we're going to take a look at horizontal shifts on how we can manipulate the graphs of basic functions. Right now, we're just going to look at the same two functions. We're going to look at the cubic function and the square root function and how we can really easily we know what the first one looks like, we can get another one really quick, just kind of a quick sketch, just by knowing the first and then doing a little something to get to the second. So, first off, a horizontal shift. Given the graph of f of x, the graph of g of x equals f of x plus c will be the graph of f of x shifted left by c units if c is positive. So if it's positive, we're moving left. That's weird. We're moving backwards, right? Or right by c units if c is negative. Now, I don't really like this so much. I like to kind of flip it around. I'll be honest with you. And so I kind of like to do this. So let me show you this here. Instead, we can say if we have g of x equals f of x minus c, then we move c units right. And we move c units to the right, we should say, if c is positive. So let's say if c is greater than or equal to 0, we move c units to the right. There we go. If c is less than 0, so if c is negative, we move c units to the left. And that's saying the same thing as what's above there. It's saying the exact same thing, right? But it's just a different way of thinking about it. If it's x minus c, so in other words, we'll see it right here. We'll show you, okay? So right here I have f of x minus c. In this case, c is 3. So now it's x minus 3. Is it going to move to the right or to the left? Well, here's my square root of x. Here's square root of x minus 3. What happened? It didn't move to the left. It moved to the right. And that's where you got to be really careful with these, is that it's very unintuitive. Whatever's opposite of in here, since that's negative 3, you would think, I'm going to go to the left. It's going to move left. No, it doesn't. It moves to the right. So why does it move to the right? Why does it do the opposite of what we would think? And this is the way I like to think about it. To get this point here, 0, 0, right? The lowest point, the vertex, well, let's say, of our square root of x function. To get that, we plug in 0, right? Well, now, if it's x minus 3 now, how do I get a 0 under my root now? What do I got to plug in? I got to plug in something 3 higher than I had to before. So now if you think about it like that, it becomes really clear and easy. Oh, I'm having to plug in values 3 more than I had to before to get the same y values. That means everything shifted to the right 3. And that's the way I think about it. And it makes a lot of sense if you think about it like that. And we can see that's exactly what's happening here. 3 minus 3, that's 0. Square root of 0 is 0. Here's another point, right? 1, 1 in our first graph. Square root of 1 is 1. But now to get 1 under the root, what do I need to do? I need to plug in 4. I need to plug in 3 higher than 1. So this point here is 1, 2, 3 more to the right. Every point, here's a point in our blue graph, 1, 2, 3, 3 more to the right in our red graph. That's exactly what happens in these. And it can become very clear again if you compare these tables. Right? Look, before we had to plug in a 0 to get 0 in our y. How do we get a 0 in our g of x? Well, it's 3 more. That's how we get the 0. This value is 3 more in our x. This value doesn't show up unless I go 3 more in my x. So we can kind of look at the table there and kind of see those as they go about. Now let's go ahead and play with this a little bit. So if I had, let's say negative, I don't know, let's go negative 2. Of course, f of x minus c, so this is going to get me square root of x plus 2 because it's minus negative 2. And again, that's the way I think. So it's minus negative 2. Now I move 2 to the left. That's the way I like to think about it. No matter how you think about it, as long as you pick one and you're good at it, you're going to be all right. But now, in order to get back at that my point that I always know I have in my square root function, my basic square root of x function, I got that 0, 0 point, that vertex. Well, now how am I going to get 0? I got to plug in negative 2. I got to plug in something 2 smaller, 2 to the left. So I know everything gets shifted 2 to the left in this case. All right? So that's how we can see the relationship between these and how we can get a horizontal shift. Another example here is cube root of x, right? So now instead of cube root of x, what if I had, c is 3, cube root, I have here I have g of x equals f of x minus c again, because I like to do the minus c. So if c is 3, I get x minus 3 cubed. That's 3 to the right, once again, because before I had this nice little point here, 0, 0, that's right in the middle of my cubic function. But now, to get 0 cubed in here, I got to plug in 3. 3 minus 3 is 0. That's going to move it over right here. Let me see if we can get that point to show up. Yes. Okay, so now I can see there's my 3, 0, because I got to plug in 3 now to get that same value in my y. I got to plug in something 3 more in my x, 3 higher. All right, and you can see that each of these points, this point, 1, 2, 3 to the right. This point, 1, 2, 3 to the right. Everything's getting shifted to the right 3. Once again, if I have something like, let's see, minus, we did that. Let's go c minus f of x minus negative 1. We do that. What do I get? I get x plus 1 cubed, which is really x minus negative 1 cubed. That's 1 to the left. 1 to the left. So everything's moved 1 to the left. And so that's what happens when we kind of change these functions. What we're doing, another way to think about this too, is we're changing our inputs. Before we're changing the outputs, we were changing the y values because it was off to the side of the function. It was, do f of x and then add something to it or subtract, and that's moving it up or down. Here we're messing with our x values before our function does anything. We're changing our inputs. The inputs are our x values, so it makes sense. It would move it left and right. Okay? So hopefully that helps you understand these and gives you a little intuition with these. All right? That's a quick little explanation here. So if I was given a problem that said, hey, do a quick sketch, all right, of, let's get rid of these again. If I had something that said, give me a quick sketch of x minus 4 cubed. I was given x minus 4 cubed. What would I do? I'd say, hey, I need a point. I know I usually have a point at 0, 0, but now it's x minus 4 cubed. So now I know I have a point at 4, 0, and it's going to be like a parabola from there. So, and then I know, well, if that's my new 0, 0, move over 1, 1 cubed is 1. Move back 1, negative 1 cubed is negative 1. It's really easy to kind of take what I know about this graph, just shift everything over to the right. Anyway, I know this is the center. I know it's going to go up and around like this. And we can take a look and see, is that what really happens? Yes. We got that nice little thing there. So that's just a quick way we can sketch these guys out really easily. Okay. So thank you for watching. Until next time, enjoy doing math.